we are now ready to implement our LeakyReLU activation function. So let's go ahead and open the editor window. Let's name it like this, and let's say that omega is the argument of the function, and let's say that alpha is the leaky, and let me quote this because I don't know if this is the standard terminology, is the leaky parameter. So the parameter that controls how negative numbers are affected. And we want this to be a parameter because we may want to change this as we perform several experiments with our neural network, and that's why we won't hard code it in here. It's a parameter that you can give to the function. And so basically, let's go ahead and test this out. The input to the function will be a series of numbers, some positive, some negative. And what we want to do is leave the positive ones untouched and multiply the smaller ones by the leaky parameter. Let's call it A, just for this test. And basically we're just going to select the positive and negative numbers and multiply the negative ones with the leaky parameter and add everything. So it's quite simple. If you have no idea what I'm talking about, go ahead and check the previous video. So basically we can get the negative numbers by finding the minimum between 0 and the input, and we can multiply this with the leaky parameter, and then we just need to sum this to the positive numbers, which is 0, the maximum between 0 and the input. So this is our LeakyReLU. It's quite simple, and the beauty of it is that it works for arbitrary arrays as inputs, because we are using, this is not imp, it's omega, because we are using scalar functions everywhere. Then again, omega, I think that's it. Let's press escape. And let's try this out. Of course, I forgot to give the the leaky parameter. Okay, so let's press escape to close the trace window. We can go right ahead and say that the leaky parameter is 0.1. We can change it to 0.0, and we can even make it greater than 1. We are not going to, but we could. And maybe we can give in a larger input, like concatenating it with it itself. So as you can see, it seems to be working. So now that our activation function is working, the next step is implement a function that takes the network input, takes the network, and then performs all the calculations necessary so that on the other end of the network, we get the network output.